Welcome everyone to Engineering Economy, and today we'll have an extra example for the break-even analysis when we have two alternatives. This example, it has two options or two alternatives. One of them is to have a machine or two machines, let's say, to perform the job, or to have an equipment that is made in-house, or two machines to be purchased. The example here needs some attention to the wording, because the wording here, it may mislead, especially for the variable cost when we comes to the quantity. So let's read the question, and I would like to highlight the things that you have to pay attention when you read such problem like that and the break even. A Guardian is a national manufacturing company of home health care appliances. It's faced with a make or buy decision. So either they make this equipment or they buy it. A newly engineered lift can be installed in a car trunk to rise and lower the wheelchair. The steel arm of the lift can be purchased for 60 cents per unit, made in-house. So this is if you have decided to make this in-house. If manufactured on site, two machines will be required. So if they are going to manufacturing those, two machines will be required, and the information for those two machines is given in machine A or machine B. So either they purchase or they made those in-house using those two machines. The purchasing option, the only information we have about is the 60 cent per unit. And that is considered to be a variable cost because it is related to the quantity. When it says per unit, that means it is related to the quantity. So if we increase the number of quantity, it will increase. If we reduce it, it will reduce. The manufacturing option or the making in-house option will require two machines. Those two machines, A and B, have information regarding to each one of them, but doesn't mean we can separate them. We have to deal with them as a one unit because all of them belong to the same option. So we have to read the information about them very carefully. The estimated cost for machine A is 18,000, and the life years is 6, and it has a salvage value 2,000, and annual operating cost 6,000, and it will require an overall cost after 3 years costing $3,000. Giving those information, estimated cost, that is a present cost or initial cost, because it says estimated to cost, and that's mean the purchasing cost for this machine. And have a life years, which is the number of years of this alternative, 6 years. And we have a salvage value, which is the inflow value, 2,000 comes at the end of year 6. And annual operating cost is 6,000 per year annually for 6 years. And then there is additional cost comes after 3 years on a cost of 3,000. For machine B, we have 12,000 cost initial or principal, and the number of years is 5, and there is a salvage value but with a minus. This is the first time, and it says here carry away cost, because these type of machines, it needs contamination in a special way. So even getting rid of those machines, it costs as a salvage, but you pay it, is not that you sell it for. So, and the annual operating cost is giving 5,000 per year. All this information sounds okay and sounds familiar, and it can be changed over the time format into annual or present. Well, we decided earlier to use the annual since it is more easier to deal with, and especially when we have alternatives, we are not going to deal with the LCM or so. Now here is the information where it needs the attention. A total of 4 operators will be required for the 2 machines. So how many people they will work? 4, and is not an option, and so it's a must to be 4. And their rate is $12.5 per hour per operator. These two information are very important. Well, if it says only per hour, that means the 4 operators costing $12.5 per hour. But when he says per hour, per operator, that means every operator, every single operator costs $12.5 for the hour. So when we have 4 operators, we have to multiply this number with 4 in order to get the total cost for the 4 people or 4 operators per hour. Okay, let's continue. 1,000 units will be manufactured in a normal 8-hour period. So the working time for this manufacturing is 8 hours. The period is 8 hours. Okay, and we have the cost per hour for the operators is 12, and we said we are going to multiply it with 4 because we have 4 operators. We have to multiply it also with 8 because the working days consist of 8 hours per period. So we have to multiply this 12.5 with 4 to get the total cost per hour for the 4 operators, and then multiply it with 8 to get the cost per day, which will produce 1,000 unit. This 8 hour will produce 1,000 unit. How much is the unit cost? And this is what we always look for when we talk about the variable cost. The variable cost is the cost that associate with the number of quantity. So always our ultimate question is, what is the unit cost? How much the cost for that single unit? If we have 1,000 units will be produced in 8 hours, and we have the cost per hour for the 4 operators, we can get the unit price by dividing over 1,000. How we will do that? I will skip this slide here and come back again. The 4 operators cost 12.5 for each one of them. When you multiply it with 4, you get the cost for all those 4 operators per hour, which gives you $50 per hour. This $50 per hour, if you multiply it with 8, because the period has 8 hours, you will get 400 for every period. That means every period, the cost for the operators will be $400. And that will produce 1,000 unit because the period has 1,000 unit. The cost of the unit for the single unit, we divide over 1,000. So we will have 40 cents or 0.4 for the unit, for the single unit. Comparing now, this is the variable cost. All these considered to be a fixed cost because those are not associating with the quantity. This variable cost is 40 cents or 0.4, whereas the purchasing option was a 0.6 cent for the unit. Looking now only for the variable cost, the purchasing is more expensive compared to the manufacturing or making in-house option. However, we have not yet calculated the total cost for all of them. Even though for the purchasing option, this is the total cost because there is no fixed cost. It is only variable cost. But in this option, for the making option, there is a fixed cost need to be calculated first so we can compare them to each other. We have to assume or use a 15% as an interest rate, and the question says the number of units to manufacture each year to justify in-house or make the option. That means you have to find the break-even quantity. When it says number of units to justify the other option, that means what is the number of quantity you need to balance the both options, which is the QBE. What is the maximum capital expense justifiable to purchase the machine A? Assuming all other estimates for machines A and B are stated, the company expects to produce 125,000 units per year. So he gave you a production rate in this part, and he asked you how much is need to justify or to have an expense enough to purchase the machine A. In other words, we have to compare the QBE with this given production rate and see which one is more, okay? Let's do it one by one. So let's have the QBE. In the QBE, we have to equalize the both costs for the both alternatives. That means we have to equalize the 60 cents per unit because this is the only cost we have for the purchasing option with all these costs here, the fixed and the variable for the manufacturing or making in-house option. The variable cost is being calculated to have it $40.4 dollars. For the fixed cost for machine A, we have to convert all these values into an annual worth. Converting the 18,000 from P to A using the N equals 6 and IR equal 15 will lead us to minus 18,000 A given P, because A is needed and P is given, for 15% and number of years 6, plus 2,000. The 2,000 came from here, which is the salvage value. That is a single value placed at the end of year 6. So A given F, a single value given in year number 6, minus 6,000, because this is the annual operating cost, minus 3,000 P given F for 3 years, and then we multiply it with A given P for 6 years. Why we did this step? Because we have another single value, but this single value here, it's a cost placed on year 3. If it is placed on year 3 and we would like to have it as an annual, we have to convert it first to a single side, to one of the sides, either in the future on year 6 or in the present on year 0. And then we can convert it to an annual using A given F or A given P. So the first step to do that, we here decided to convert it into present using P given F for 3 years because it is placed on year 3. And then we converted to an annual using present for 6 years. You can also use the same value here and use A given, F given P for 3 years, and that will take that value into year number 6, and then A given P for year 6. And when we calculate all these values, it will give us the annual worth for machine A, which is the $11,000 per year. For machine B, we have to go back and review machine B cost. We have initial cost need to be converted into an annual using A given P for 4 years minus 500. This is the first time we use the salvage with a minus sign, which is the 500 A given F for 4 years, and the annual operating cost does not need to be changed. It is already on annual 5,000. The $12,000 for the initial cost, A given P, the 0.5 thousand, which is the salvage with the minus sign, because of it is a carry away, not a regular salvage, for 4 years, and minus the 5,000 annual operating cost. When we calculate those values for machine B, we will have $9,000 per year. Now we have to put the annual worth for B and annual worth for machine A together and add them, because both of them now in the same time format, which is the annual. And the annual for the making option will be that time the 11,000 for the annual machine annual worth for machine A, the 9,000 the annual worth for machine B, minus the $0.4 times Q, which is the variable cost for the making option. When we all of them up, we get the total cost for the making option, which is the $20,000 minus the 0.4 times the quantity. Now we have in the break even, we have to equate the cost or the total cost for the two options and see how much is the or how much is Q equal to. Well, we have to equate this part with the only cost we have for the alternative buying option, which is the 0.6 Q. So we put 0 minus 0.6 Q, because 0, this is for the fixed cost, it is 0 here, minus 0.6 Q, this is the variable cost for the buying option, equal to the annual worth cost for the making options, the total cost, the minus 20,000 minus the 0.4 Q. Now to get the Q, we will solve this equation for one unknown, which is the Q, and we will get the 101,762 units per year. This is exactly the QBE, the quantity for break even. Now, what is the interpretation? And this is very important. Expect to have this question, what does this number means? What does that mean? This number means a minimum of 101,762 lifts must be produced each year to justify the making option, which has the lower variable cost of 40 cents per unit, meaning that you have to produce this number, so the making option and purchasing option, they will be at the same cost. Otherwise, if the number of production is increased than this number, then we will go with the lower variable cost. And that exactly what the part B says. If the production level is above the break even, so what is the best option to choose? We go with the option that has the lower variable cost, which is we have the 0.6 for the buying and 0.4 for the making. And in this case, we will have the making option is the one to be selected based on the criteria. If we go back to the criteria, if we have the Q greater than the QBE, then you select the lower alternative cost. In this case, we have the making option is the lower variable cost because it is 0.4 compared to the buying option, which is 0.6. Now, since we knew that it is the one has to be chosen, now the question is, says, let's go back to part B and see what was exactly. He wants to see what is the maximum capital expense justifiable to purchase machine A. That's mean how much the cost for machine A, if it increased and still can be taking the making option. Now, this question is a little bit tricky now. Is since this number of production or the production level given, it is greater than the break even, this means we are going to go with this option, the making option. The part B says, okay, we know that you are going with this option because it has the lower variable cost. But what about in the fixed cost, if that cost, the 18,000, is being changed, being increased? How much is the maximum cost for machine A you can carry and still go with the making option? That's mean you will come to a level, if machine A, let's say, comes to 50,000, let's say just dollars, then the number of quantity of the QBE, it will not show that the lower variable cost comes to this side of the alternatives. So what we have to have here, how much is the maximum we can deal or we can handle in terms of keeping the QBE for the side of the making option. So basically what you have to do, you go back to the step where you had all the fixed cost for the making option and try to solve the equation for the first cost or the initial cost for the machine A. If you go to the making option here, the buying option, nothing changed because the quantity is given, the 125. The only change will be different for the making option on machine A, which means on this part only. This part only here. The 18,000 will be considered to be unknown, and we refer to it as PA. PA. And we put the value of the converters A given P, 15% and 6.264 as is, no changes, okay? We will leave it as is. And all the remaining values here will remain the same. So at the end, you will get, instead of the 11,000, you will get PA, which is the unknown, times this value, plus the sum of all those which is given here in this side, because this side contain the machine A and the value of machine B, because the value of machine B also will remain the same, which is the 20,352. So basically, this is the initial cost for machine A, and everything else remain the same. And you solve this problem for the unknown P given PA, and that will be the maximum cost, meaning that instead of the 18,000, the maximum we can put here is 38,000. If we exceed 38,000, then we cannot go with the making option anymore, and the buying option will be better. And this exactly what is explained here. This means that the approximately twice estimated the first cost of the 18,000 could be spent on machine A, or on machine A. Meaning, if this machine A, it is double the price, you still can go with that option, because still the making option will be the good option in that case. So what we did in this step here, remember, we solve all the equation for the machine A, having, instead of the 18,000, we have it unknown because we want to see what is the maximum it can be handled with that quantity of the production. And also we solve those as is with no changes, and we use the quantity of production that is given. So we solve it here and we get the amount that is the maximum can be used with this production level. Remember, this problem or this question is ask you to see what is the maximum you can purchase machine A. Both also, whatever we did here in machine A, it can happen to machine B. You can apply the same thing for the same production level, and you solve the problem for machine B and see what is the maximum cost you can pay, or what is the maximum annual for machine A, or what is the maximum annual for machine B. So it can answer many questions to you as a decision maker, and tells you what you can do with the quantity if it is increased. Although that it goes with the lower variable cost, but if there is other cost is being changed, like in the fixed cost, even though they are fixed and they are not related to the production, but assuming that the operating cost is being increased due to taxes or to other circumstances that is externally. So that was the second example here for the break even. I hope that was, and here I will use this time remain to answer any questions you have regarding